Okay, question number 3 asks us to express cos 2 theta in terms of cos theta. So that's what I'm going to do. I'm just going to see what happens. We know that cos 2 theta is, well, it's a few different things. It can be cos squared theta minus sine squared theta. From there, if we replace sine squared theta with 1 minus cos squared theta, that means that we can rewrite it as 2 cos squared theta minus 1. And that's the one that they want us to use. They want us to use the one just in terms of cos theta, or cos x in this case. So, how can that help us with this question? Well, there's a cos 2x in the question. So let's replace that cos 2x with what we've got here. 2 cos squared x, take away 1 over cos squared x. But why is that useful? Well, that's useful because we can now split these into 2 separate fractions, and we can write 2 cos squared x over cos squared x minus 1 over cos squared x. And here, obviously, you can see that the cos squared x's cancel, so that's just a 2, and 1 over cos squared x, well, that's sec squared x. And sec squared x happens to be something that we can integrate. Hopefully you know that the integral of sec squared x is tan x. So we can integrate 2, we're going to get 2x. Integrate sec squared x, we've just said we're going to get tan x. And this is between pi over 3 and pi over 4. So, if we put our numbers in now, if we put in our limits, we're going to have 2 lots of pi over 3, take away tan of pi over 3, minus 2 lots of pi over 4, take away tan of pi over 4. That obviously is just 2 pi over 3 still. Tan of pi over 3 is root 3. That's pi over 2. And tan of pi over 4 is 1. So we can get rid of all the brackets. We've got a 2 pi over 3 minus a pi over 2 minus a root 3 plus 1. And these two terms we can group together. 2/3 take away half is a 6th. So we've got pi over 6, pi over 6, take away root 3 plus 1.